Question 1, Part A. Which of these quantities is a vector? So we've got A, acceleration, B, energy, C, power, and D, speed. A vector quantity has got both magnitude and direction. So let's have a little look and see if we can work it out through process of elimination first. D is incorrect because speed has only got magnitude. Power has also only got magnitude, so is incorrect. Energy is incorrect because it only has magnitude, which leaves us with A, acceleration, which we know has both magnitude and direction. 1, Part B. Which of these is the correct unit for momentum? A, kilogram meters per second. B, kilogram meters squared per second. C, kilogram meters per second squared. Or D, kilogram meters squared per second squared. Now then, the correct answer to this is A. And if we think about the unit for momentum, we can work it out quite easily from the equation for momentum, which is mass times velocity. The unit of mass is the kilogram, and the unit of velocity is meters per second squared. And there you have it, Part A. Moving on to question 1, Part C. The photograph shows a toy train at rest on a horizontal surface. The first thing I would do is underline that, at rest. If something is at rest, it is not moving at all. So, why is the toy train at rest? A resultant downward force acts on the train. B, a resultant upward force acts on the train. C, no resultant force acts on the train. Or D, no forces act on the train. The correct answer is C. There are no resultant forces acting on that train because it is stationary, it is at rest. If a resultant downwards force was acting on the train, this would look very strange because if it were true, the train would be accelerating downwards into the horizontal surface. B, a resultant upward force was acting on the train, that train would be flying, it would be levitating upwards. Or D, no forces were acting on the train. We know this is untrue because that train has got weight, it's got a reaction force. Part 2. The mass of the toy train is 150 grams. So, important information, mass of the train. State the equation linking weight, mass, and gravitational field strength, G. Now, you can write this in symbol form or you can write it in word form. So, as words, it would be weight equals mass, multiplied by gravitational field strength. Or, more simply, which will probably look a lot nicer on this, W equals mg. And there's one mark available for that. You are not allowed to write gravity for g. That is not allowed. The next part of the question asks you to calculate the weight of that toy train. So you're just using that equation that you've just written down. So to find the weight of the toy train, you must use the equation W equals mg. Now, we are given a mass of 150 grams. Okay, and we are also, we know G. We know G to equal 10 newtons per kilogram. Okay, on Earth, remember, 10 newtons per kilogram. Using grams as the mass is not acceptable, okay? You must change that into kilograms. So that is 0.15 kilograms. Okay, so W equals mg will equal 0.15 multiplied by 10, which equals 1.5 newtons. Okay, 0.5. You are allowed to use 9.8 or 9.81 for your value of G, okay? But for GCSE, IGCSE level, using 10 is perfectly acceptable. And that is the end of question 1.